Eyes. We all have them. It allows us to see, and is considered to be an important aspect in how you look. But you can change how you look now. You can change your eye color to whatever you want, even a rainbow. But what is behind these eyes that makes them work? Well, first, let there be some light. Now this light is registered by rod and cone cells. Rods read less intense light and are responsible for your night vision, whereas cones read more intense light. When these cells respond to light hitting them, they send out a signal to bipolar neurons which contain the intensity of the light that the rod or cone read. Now the first thing that this neuron does is make sure it's on the correct side of the brain. So anything seen from the left side of your right eye will head to the left side of your brain. Now a strange thing is that they cross part of your brain that regulates hormones and daily cycles, including part of your brain that tells you when you should start getting sleepy. Next they enter the lateral geniculate nucleus. From here they move on to the visual cortex via optical radiation. In the visual cortex, two main cell types have been identified, one for identifying shapes, and another for reading color. The neurons were only able to carry the charge of the white light, but these cells are able to take the white light and turn it into all the colors that we know of today. With this we can see anything in our world, and we can even get a glimpse of our own galaxy. But some people aren't as fortunate as we are and can't see a single thing. So how can we take this eye and turn it into this eye? We can't, yet, but we might be able to do something more along the lines of this. But to consider doing this, we first have to understand these. In this case, our white light is turned into electrons which store the intensity of the light in binary code. Now for this signal to gain color, it has to run through a Bayer filter, which might produce an image kind of like this. Now to get a better image, algorithms take one square color and compare it to all the squares around it, then averages all the colors replacing the middle square. Using that might make a second iteration look like this picture. And say a third one might look more like this. After enough iterations though, you'll end up with a very clear picture. But if we want this to be a reality, we can't exactly use that method. We have to stop it at the binary code stage. Here nanobots take the electron, read the binary code, and then send a signal telling the neuron the correct information, sending it on its merry way through the brain, which was explained earlier. So yes, this does make for some complex work, but it's possible. And in time we may have eyes that zoom in and focus on command or who knows what. But for now we can make this a reality, and this a thing of the past.